Question number 41. In the extraction of iron in the blast furnace, limestone is added as a flux. Select the option which represents the composition of the slag and the temperature range at which the slag formation takes place. So students, if we talk about the extraction of iron, so limestone is added as a flux. So CaCO3 is added as a flux. Okay, so what happens is this iron, it contains silica as an impurity. So due to heating, this calcium carbonate decomposes to give us calcium oxide and CO2, and then this calcium oxide and this SiO2. So there is an acid-base reaction leading to the formation of the calcium silicate, CaSiO3. And this slag formation, students, it takes place in the temperature range of 900 Kelvin to 1500 Kelvin. Okay. So students, if we look at the options which are given to us, we can clearly see that the correct answer is option 1. Let us look at the next question now. Question number 42. In the Hall-Héroult process of reduction of alumina, an electrolytic cell is used. The electrodes used in this cell as cathode and anode respectively are. So students, in the Hall-Héroult process, the cathode which is used is a steel vessel along with a lining of carbon. Whereas if we talk about the anode, we use graphite anode, and we also know that these graphite rods have to be replenished after the reduction process. Okay. So students, if we talk about the correct option, we can clearly see that the answer to question number 42 has to be marked as option 4. Let's look at the next question now. Question number 43. Ligands can be classified as simple ligands and pi acid ligands. The pi acid ligands are generally more stronger ligands as they cause synergic bonding. Which of the following is not a pi acid ligand? Okay. So students, if we talk about these pi acid ligands, they are sigma donors generally, and they are pi acceptors. So due to this sigma donation and pi accepting tendency, students, they act as strong field ligands. Now students, for this ligands to be pi acceptors, there has to be vacant orbitals where the back donation of electrons from the metal to the ligand can take place. So if we talk about the CO, students, CO has a pi star vacant orbital, and the back donation from the metal can take place in the pi star orbital. If we talk about Cn negative, the Cn negative also has a pi star orbital. If we talk about PPH3, which is the triphenyl phosphine, so PPH3, it has a vacant d orbital, and into this vacant d orbital, the back donation of electrons from the metal can take place. If we talk about the fourth one, which is the OH minus is not a pi acid ligand. Students, for question number 43, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 44. In the square planar approach of ligands, select the relation between energy of the d orbitals which is correctly represented. So if you talk about this square planar approach of ligand, students, in this square planar approach, the d x square minus y square orbitals, they are directly facing the incoming ligands. So these will be repelled to the greatest extent, and as a result, the energy of dx square minus y square has to be the greatest. Now if we talk about the other orbital, students, so we have dxy. So after dx square minus y square, it will be the dxy which is repelled to the greatest extent, because these contains orbitals at an angle to the incoming ligands. Next, it will be dz square. So the dz square will also be repelled because of the ring or the tube it contains in the xy plane. And lastly, the orbitals which will be least repelled is the dzx or the dyz. Okay, so these will be equally repelled, and as a result, their energy will be equal, and this will be having the least energy among all the given orbitals. So students, now if you look at the options which are given to us, we have to select the energy relation which is correctly represented. Okay, so if we talk about the first option is not correct, students. Dx square minus y square has the greatest energy. If we talk about the second option, we have dzx and dyz, and they are given to be equal. So this is the correct option, students. If you talk about the third option now, it says that dz square has a greater energy than dxy. So this is not correct. The dxy has a greater energy. They are repelled more as compared to dz square, and as a result, their energy is greater. If you talk about the last option, dx square minus y square has the greatest energy, and as a result this option is also not correct. So students, for question number 44 we have to mark the correct answer as option 2. Okay. Let us look at the next question now. Question number 45. Some complexes are given below. Select the one which is inner orbital complex and paramagnetic. Okay. So we have to select an inner orbital complex which is also paramagnetic. Okay. So if we talk about the first option, students, we have Mn F6 4 negative. So Mn is present in a state of +2. So it has a D5 configuration along with a weak field ligand. So the weak field ligand will not cause pairing. So it will be outer orbital or sp3d2. So this is not correct. If you talk about the second one, students, we have Ni F6 4 negative. So Ni is again present in a state of +2. So it has a D8 configuration. So students, in this D8 configuration, it does not matter what the type of ligand is. It will always be an outer orbital complex. Okay. If you look at the third option now, students, we have chromium trioxylate. So we have chromium in a state of +3. So it has a D3 configuration. So D3 configuration will generally form inner orbital complexes, and the 3 electrons which are present in the d orbital will be unpaired, so it will be paramagnetic. So this has to be the answer to this question. If you talk about the last one, which contains Zn+2, so Zn+2 has a D10 configuration, so it does not matter what the type of ligand is, it will always be outer orbital complex. Okay. So students, for question number 45 we have to mark the correct answer as option 3. Let us look at the next question now, students.